Hello everyone. Tehleel is one of our student of this class and he is going to explain you about the servo motor, and let us understand that how he is going to explain the servo motor in the flip classroom mode under the EDU revolution. Thank you.
Very good morning to everyone. I'm Tehleel Nisar and I will be presenting a topic that's the interfacing of servo motor with the Arduino Uno. Basically, we are going to touch the three basic concepts before interfacing. One is the servo motor, second is the PWM signals, and third is the servo H library. These are the three main concepts that we are going to touch before the interfacing. It rotates anti-clockwise, clockwise, but there are two motors. One is DC and another is the servo motor. So we have to differentiate between the two first of all. What servo motor is and what the DC motor is. First of all, we will talk about the servo motor. Servo motor is basically the position actuator. The one term you can give it about it, it's a position actuator. Its position can be controlled by the signals. The signal we are using in this for controlling the servo motor, we have the PWM. That's the pulse width modulation. This concept we are going to talk about later on. First of all, we will know how servo motor is being controlled. The position of servo motor is being controlled only because of this pulse width modulation. Unlike the other DC motors which continuously keep rotating, but the servo motor rotates to the specific angle. It has a precise angular control because of the PWM. And we use this servo motor in various things. First of all, you have seen the RC cars. You have seen various robots which move to the certain positions because of only this servo motor. This servo motor, what is the basic funda behind this servo motor? How it's able to recognize the position, at which position the servo motor is currently. We have a main feedback mechanism in the servo motor. Position sensors, or we call the potentiometer, to actually calculate the angle at which the servo motor is currently. And third, we have the external or the controls. We have the control circuit, which basically receives the pulse width modulation from the Arduino Uno. Talk about the DC motor. In the DC motor, we have the rotation that continuously keeps rotating rather angle. And we have some specified servo motors as well that can rotate to the 360-degree angle. Second is the control. How basically in the DC motors, when we talk about the DC motors, they keep continuously rotating, but how to control their voltage, how to control them? We control them by using the voltage. We either decrease the voltage, either increase the voltage. By that we can control them. But in case of servo motors, we have the PWM signal control. Gives you the angle, current angle of the servo motor, and according to that the servo motor keeps rotating. And the servo motor is being used in the robotics and automation. There are the four main components of the DC servo motor. Firstly is the DC motor, second is the gear train, and then we have the potentiometer, and then we have the control circuits. So first we talked about the servo motor. Now we are going to talk about the pulse width modulation. This voltage is being controlled by this PWM signals. If you send the pulse width of 1 milliseconds, it will rotate to the 0-degree angle. If you rotate to the 1.5, if you give the pulse width modulation of 1.5 milliseconds, it will rotate to the 90-degree angle. And if you give the 2 milliseconds, it will rotate to the 180-degree position. And this all is being controlled by this PWM. When you talk about this PWM, it refreshes its cycle after 20 milliseconds. See, if you have to rotate to the 0-degree angle, if it's at the 0-degree angle, we will give the pulse modulation of 1 millisecond, and it will rotate to the 0-degree angle. After that, there will pulse width modulation will refresh its cycle for the 20 milliseconds. There will be the gap of 20 milliseconds. You all may have noticed it in your lab as well. It doesn't rotate directly from 0 to the 190. It takes a 26 milliseconds of space between the two rotations. After that, if you go for the 180-degree angle, there will be the 2 milliseconds. 2 milliseconds pulse will be produced by the PWM, and you will be able to rotate it to the 180-degree delay of 1 second again. This is the interfacing, basic interfacing of this servo motor with the Arduino UNO. We have used the 3 pins. That's first of all what we talked about. We are going to use the ground. We are going to use the VCC, which we have connected to the 5 volt, and we have used the one PWM signal, that is the 3, to give the signal towards this servo motor. We have talked about the 3 main concepts that are being used. First off, we have talked about the servo motor, PWM, and the servo.h library, and we have talked about the interfacing of this servo motor with the Arduino UNO. This was all from my side. Thanks.